Okay, so we are now recording. So good evening, UNSY 501 students. First, just for everyone's awareness, we are recording and a copy will be made available for those who are unable to attend. Next, for the format for tonight's meeting, I am going to start by introducing our guest, who will describe his organization's involvement in uncrewed aircraft system technology infrastructure development. Afterwards, I'm going to lead a series of introductory questions, after which we're going to open up to a class-wide Q&A session. I do ask that you mute your mics and save all questions to the end, and that you use the hand raise icon to indicate when you do have a question. I'll call on each of you and in order. I also want to note that I'm going to be capturing and sharing online links to important concepts, details, and tools that are brought up in our discussion tonight. You're going to be able to find these in the video notes of the discussion area tomorrow. So with that, I am thrilled to welcome you to the 15th session of the UNSY Guest SME Speaker Series. I'm Dr. Brent Terwilliger, the Program Coordinator for the Master of Science in Unmanned Systems degree at Embry-Riddle. And tonight we are joined by our guest subject matter expert, Mr. FBonset from the VHB, where he serves as the Director of Aviation Services. I borrowed some bio material from an online article. Hope you don't mind, Finn. So he joined VHB in 2016, where he serves as an experienced and accomplished aviation development consulting professional. He has more than 2 decades of experience in both the domestic and international markets, and has helped them to establish new norms in aircraft and airport planning. Tonight, Finn will be talking to us about what VHB does in the unmanned and autonomous system space, how he sees the technology changing the world around us, and challenges that will need to be addressed in the coming years. With that, I'm going to turn the stage over to Finn.
Sure. Thank you, Dr. Terwilliger. Again, welcome everybody. Thank you for having me. It's an absolute honor. I even wore Embry-Riddle blue today, even though I'm a Florida Tech grad. So don't hold that against me. I know FIT and Embry-Riddle have a pretty good rivalry, but no, honored to be here. Indeed, as Dr. Terwilliger said, I'm an airport planner by trade. So airport planning, airport master planning is big picture idea of infrastructure development at airports mostly, right? So even when I say international experience as a consultant, going through full master plan efforts from inventory, forecasting aviation demand, demand capacity analyses, CIP planning for capital improvement programs, and now what's being integrated in this master plan realm that I'm working in the last year or two, we've gotten into the UAM, AAM, whatever you want to call them. There's a lot of different acronyms, UAS world, where we've been asked by our clients, our airport clients and city clients alike, to start looking at these autonomous type vehicles. The transition from manned to unmanned, of course, that's a big discussion point. The timing of that, I think, is important. We just talked about that offline real quick here. I just want to give you kind of an overview in terms of what VHB is working on at the moment, because there's some exciting things that are happening. We're one of the first companies to take a look at integrating advanced air mobility in different forms in working with OEM manufacturers of the actual vehicle types in collaboration with multiple stakeholders to create a plan for a city. So we're doing work for the city of Orlando right now. It's called a Smart Cities Master Plan, right? So when you say smart cities, we're talking about a sustainable, resilient, energy efficient, and ease of transportation for the general public. So it's a multimodal system. So we're talking airports, rail, Uber, taxi, whatever it is, it's all mixed together. But now you add this advanced air mobility component in the UAS world. And what's neat about this is there isn't much of a precedence in terms of planning for these kind of facilities. So we've been tasked for starting a plan in terms of how do we integrate this? What are the right locations to have these type of vehicles operating out of? What's the system going to look like? What do we have to look at from an airspace and operational perspective? What about noise? What about how these different aircraft operate? What are the security and safety risks? So there's just a lot involved. So what I'd like to do is, with your permission, I think I can share screen here. Let me give it a shot. Hopefully you guys can see my screen in a second. Just let me know. It should be a PowerPoint presentation.
Yep, coming through.
Okay, excellent. So I had the honor recently of presenting our project. And Dr. Twilliger, are you seeing my full screen, or is it basically the preview screen?
It's the full screen. There we go.
Okay, is this
Perfect.
better? Okay,
Yep.
excellent. Okay, so I was in San Diego 2 weeks ago, and we were asked to present on how we're planning for this advanced air mobility from a city perspective. So the people on the panel that were involved, and I think this is kind of the state of the industry, you can see myself there, but we had, what's important here, we had Jacques Colon from the city of Orlando. So the one thing I want you to understand here, it's a collaborative process, right? We're a consultant that brings together the stakeholders, that brings the technical expertise on airspace operations for these vehicles. And then we were also joined by, again, this is for future jobs for all you guys that are looking in the future. Crown Consulting is a very reputable company that deals with urban air mobility on multiple state and city levels. So again, these are really good people to know. On the far left was Curtis Stradka. He's our director of smart communities, also a VHB employee. But again, we've gotten some prominence based on what we're doing. We've actually been asked to speak at 4 other conferences about this, so it's very there's a lot of interest in this topic. So again, I know that the general basics, or the basics of UAM and AAM, but again, we want to explain this in layman's terms sometimes. But we talked about what advanced air mobility is. We talk about airspace basics. We talk about the actual integration of the Orlando transportation plan. And then we talked about a national perspective. So we kind of did a bottom-up approach because we want to focus on what we were doing. So again, advanced air mobility, I'm sure, I don't know if you want me to go over some of these definitions, but there is a difference between the two. If you're talking about advanced air mobility, it's essentially use cases. So when we're talking about advanced air mobility, we're talking about interconnectivity between cities. We're talking cargo. There's a blend probably of manned flight initially, but then going autonomous, which, by the way, is already happening in certain parts of the country. And I just want to stop and talk about that. Another project that I'm working on right now is up in Syracuse, New York. There is an existing UAS corridor. It's a 50-mile corridor for specific drone operations package delivery. So cargo, small package delivery, last mile delivery. Amazon is interested in the area. Walmart's already starting to operate this from a Part 135 perspective. So that unmanned portion actually exists already, and maybe that's the future, is corridors, right? So we also looked at this from the Orlando city perspective. So again, that AAM builds upon that UAM concept. So just to get you an idea, this is what we presented to San Diego. If you look at pre-COVID, right, at that point, there was already about $3.5 billion invested in advanced air mobility, right? And if you look at, for example, where the airlines put their money, United Airlines themselves are investing $2 billion, I believe, in Archer right now, one of the manufacturers. And if you follow any infrastructure development processes, there was going to be a sonic, if you guys remember, Boom Aerospace was going to come to Melbourne and build a supersonic aircraft. Part of that investment was from Boeing, but they pulled out last minute. The airport lost out on a $300 million project, and they decided to put all their money into Wisk, which is another type of UAM, AAM manufacturer for an OEM vehicle. So if you follow that money, you've got Boeing, you've got United, you've got other airlines that are investing in advanced air mobility. It's a real thing. It's happening. So as you may know, there's over 320 eVTOL concepts out there. There was 1,000 test flights conducted in 2020 alone, which is a staggering number. And having talked recently to some of my FAA friends, it's not that they can't handle the technology, they can't certify these things in the time frame. That's why the technology exists, but it's a staffing issue, because if you think about the certification of an aircraft, in this case, even an eVTOL, they have to compete with all the new variants for Boeing, Airbus, Embraer, all the aircraft manufacturers that the FAA has to certify anytime there's something new that happens with an aircraft. They have to compete with these 320 concepts on the eVTOLs. So it's a labor shortage. That's why we're not seeing a technology. I mean, the technology is out there, but the operations may happen in a couple of years from now. So again, about a $500 billion market is what's estimated. About 1.9 trillion globally. If you guys follow what the Chinese are doing, they already have autonomous eVTOL aircraft through EHang. They've got some great videos online. I recommend you check it out. Of course, from a regulatory perspective, things are a little bit easier in China. That's why they have some proven concepts already. So they're a little bit ahead of the game in that sense, especially on the autonomous side. And by the way, Dr. Terwilliger, if I'm going too far and too deep in details on this, you let me know.
That's perfect.
Okay, excellent. So why is it important for planners, right? So again, I said earlier, I'm a big picture guy, right? So when we talk to cities about advanced air mobility, to them, it's an enhanced type of mobility. It gives, an alternative transportation element, right? I mean, cities like Orlando are growing fast, rapidly. There's not a huge infrastructure development item with regards to mobile transportation around the city. So this is another option for people to be even more mobile. Regional cooperation is important. Potential for enhanced sustainability. It's a big ticket item right now. Resiliency, sustainability. That we can save costs because these are electric and also potentially fueled with hydrogen. That's the other form of having a more sustainable type of fuel. Land use planning for vertiports. I'll show you a little bit later, but a vertiport is essentially like a heliport. But the difference between a heliport and a vertiport, the biggest difference is going to be volume, because to make this model operable from a cost perspective, you have to fly a lot. You have to have a lot of these vehicles flying at the same time or taking off at pretty close intervals. So land use planning is an important element, especially when a city's trying to get ready for these higher volume traffic vertiports. Economic development, of course, you're attracting new businesses to your cities. I think that's super critical. Equity considerations, same thing. And again, proactive leadership is important, especially for cities. So I don't want to go over every single slide here. This is a very wordy one. Just want to point out the last sentence of this slide here when we talk about advanced air mobility, right? So what I was talking about, commercial intercity is important, cargo delivery, public services, and private recreational vehicles. Now, public services, from an autonomous point of view, unmanned, that's a big one because firefighting, police, those things are already being pushed by several cities. So in my opinion, before we see autonomous flights with humans in it, the test beds are really in the public services elements. From an airport perspective, drones and UAS type vehicles, autonomous vehicles are already being used for surveying runways, airport facilities and things like that. So the technology is out there. But in terms of bigger type of vehicles, I think the public services element is going to be really important and good for us to understand how this will operate. So one thing I just want to transition with, right? So we're talking about the complexities of having autonomous type vehicles within an existing airspace system, right? So essentially these eVTOLs, these vehicles have to compete with other air traffic. So even if you look at the definition of advanced air mobility or urban air mobility from the FAA perspective, they've already put in the definition that these are going to be low altitude vehicles. It's the only way that we can have such high volume of vehicles within our airspace without conflicting with commercial air traffic, smaller general aviation aircraft that are piloted by humans. That's important, but how do you organize that, right? So I want to get you an idea of the complexities involved with this. So essentially there's three kinds of airspaces, and I put that in quotation marks because they're a little bit different. But if we talk about the large scale airspace that's out there, I don't know if we have any pilots in the room. I'm a pilot myself, so I know a little bit about this, but we have essentially the big airspace that's controlled or uncontrolled airspace, and it consists of classes. So if you haven't seen this before, I'm gonna just cover this here real quick. So this is just an example of what that looks like. So it goes up to very high levels. Obviously, we've got high energy, fast moving commercial aircraft very high up. So Class A and Class E airspace all the way up to 60,000 feet. That's all controlled, which means that there's rules that govern that controlled airspace. You have to stay away from a certain aircraft. You have to stay above or below a certain aircraft. You have to stay away from certain clouds. You have to fly different altitudes depending on the direction that you go in. So all these items, right, we still have to consider that from a UAM and eVTOL perspective as well. But one thing that's important that I want to show you with this slide, you can see something called Class C, Class B airspace. And in the aviation world and the pilot world, we call those upside down wedding cakes. And there's a reason for that. These are the airspaces or airspace elements surrounding major airports, all right, or regional airports, and they're protected from the surface up. So in order to enter the airspace, you have to have one, two-way communications. Two, you have to have permission to go into the airspace. And three, you usually have to have some sort of a transponder that sends out a signal that you're there, so you can be controlled by the FAA, by air traffic control. So if you now think about that unmanned airspace, or excuse me, unmanned aerial vehicle, or even a piloted vehicle that is a drone or a UAS type vehicle, these things you still have to consider, right? So even if you're in a city as big as Orlando, if I go to the next slide here, this is the airspace that surrounds Orlando. If you guys can see it, Daytona, of course, is a little bit further north. But if you look in the middle of the screen here, those four bars basically are the four runways at Orlando, and all the yellow parts around it is the city. And you can see those blue circles that kind of go up and around the airport. There's one there that says surface SFC to 10,000 feet. Excuse me, to 1,000 feet. That's that upside down wedding cake. So if I want to go from Disney World, which is on the west side, you can see it's kind of like a white circle, to the airport, I have to traverse multiple airspace elements to even get to that point. I've got to have permissions. I have to have a special type of equipment. So if you're an unmanned aerial vehicle, right, how do you do that? Do you create specific corridors that allow you to transition that airspace? Do you coordinate with a geofence? Can you add technology in there? Can you have some sort of ground-based radar system, which are being developed as well for UAS? So it's all about control, but I just wanted to get you an idea of how complicated that is from an overall airspace perspective. And when I show planners this, even at conferences, people are like, oh my gosh, yeah, it's not only the technology for the vehicles, but it's how do we transition these vehicles around cities with all this other airspace around, right? So they're interesting concepts. And right now we're actually working with NASA as part of our team and the FAA to maybe establish some of these corridors between cities, but also within the cities themselves. Now let's take a deeper dive, right? And you may have seen some of this. If you haven't, I'll explain it real quick. So I was talking about airspace that's controlled around cities and airports, but there's also airspace that's really close to the runways. And that's called civil airport imaginary services. It's part 77, so I mean it's a federal regulation. And this airspace that is designed around runways at airports and heliports for obstacle clearance purposes, right? So within these services, they're three-dimensional services. They extend upwards and outwards around an airport. You are not allowed to build any buildings, radio towers, antennas, unless you get a waiver and it's deemed safe by the FAA. But essentially, it's the same thing for vertiports and heliports in the future, where we're going to have these autonomous vehicles. You still have to have clearance from objects. It's for overall safety. So again, I'm not going to go into too much detail because we could be here all evening. I teach a class on this if you guys want to go to Florida Tech and check it out. But what I want to show you is just how complicated the immediate airspace is near the runways. The slide that you see on your screen right now, you can kind of see a path and corridor for an instrument approach to a runway. And you can see it's a three-dimensional path, and we want to keep all of that clear of obstacles so the aircraft is protected. So it's another element that we typically look at when we're designing a vertiport for the transitions of these UAS elements. Now, this is a very wordy slide. I don't like wordy slides. Again, I don't mind sharing this, Dr. T, but just some highlighted points here. If we're talking about what a vertiport is, it's essentially like a heliport. It's the same idea. You've got a vehicle that goes up and down, can traverse vertically and then move off. The biggest difference is, number one, the size, and number two is the volume of traffic, as I said before. So having even talked, if you look at point number 3 here, the FAA may adopt a third heliport classification for commercial, or a commercial vertiport. That's been talked about. I haven't heard a lot about that development, but it's another option. Because then if you make it a commercial vertiport and you're a city, it may also make it eligible for federal funding, right? Most airports in the US are federally funded by the Airport Improvement Program. But in this case, there's no such thing as a federally funded heliport, except for one, I believe, in the United States. That's also joint military. But again, what's interesting too is that fourth bullet. There was FAA guidance on vertiports, but it was based on tilt rotor technology with normally aspirated engines, like the V22 Osprey. They did try to actually turn that into the commercial aviation world, but it ended up being too expensive. So they canceled that in 2010. But luckily for us, the FAA came out with a new engineering brief, a draft one that we as consultants, as the industry can comment on. And on April 18th, they came out with it, and they started talking about vertiports specific to AAM and UAS, right? So what's interesting is if you look at that, the second sub-bullet there, it's actually written in that advisory circular that this is meant to be for human pilot vehicles only. So the FAA is still, I know they're talking about autonomous in the future, but the fact that they wrote that in their draft engineering brief just tells me that we're not quite there yet when it comes to human transportation from the FAA perspective, which again, if the technology is there, it gets proven. It's almost like having a Tesla, right? It drives itself. If that technology exists, which it does for the most part, why not regulate it earlier? And I think the US is a little bit behind on that. So I think that's pretty interesting. But what's neat about this is the design requirements for these vertiports are based on 9 existing vehicles that are being prototyped by 9 manufacturers. So what they did is, hey, how do we size a vertiport? How do we create a sizing element? So it's based on those 9 vehicles that are in development as we speak. And then I'll talk about EASA here in a second as well. But I wanted to show you what that looks like. So in today's world, and this is directly from the advisory circular, so recommended guidelines for designs. This is for the heliport. So you can see in the center, they've got an H, that's the landing area, that's the concrete pad. Around that is what's called the FATO, the final approach and takeoff area. It provides a little bit of a safety buffer for that helicopter to land safely within the H area. And then around that is called a safety area, and that is to keep it clear of obstacles. So very simple design. This is what most heliports in the world look like, or helipads. And then to your right, you can see again that Part 77, that surface that protects the aircraft that comes in or out from obstacles, right? So very similar. So then if I go to the next slide, this is what's interesting. What has the FAA done? You're thinking, oh my gosh, this is going to look totally different. We've got these cool, eVTOL vehicles. Well, not too different. All they've done is kind of change the symbol. So in the middle, okay, here's a vertiport landing area. Now they did change the dimensions. The CD means the controlling dimension. So instead of with a helicopter where you have one blade, that's typically the longest part of that aircraft. This is based on the longest section, including rotors, right? So it could be longitudinal or lateral. So again, it's a controlling dimension, but it's identical. You have a TLOF, a FATO, and a safety area. And you can also see they didn't mess with the obstacle clearance requirements on the right. So the same protected airspace is still there. So not too dissimilar, right? But then again, if you look at what the Europeans did, this is EASA. So this is from the basically the European Union FAA. They've created a vertical component to a vertiport, and they made it into a V. So, and this came out, I think, about a year ago, maybe 8 months ago. So they're a little bit ahead. So I thought this was kind of neat because they are thinking about that vertical control right off the bat. Very similar to a safety area, but slight differences. So the world is still, what I wanted you guys to get out of this is that, there's still design elements that could be brought into designing vertiports for UAM or, UAS type operations. So I just wanted to show you that's kind of the state of the union. Me as an airport planner, airport designer, I try to keep up with this so I can help clients design these. But if you think about a vertiport and you think about the future of autonomous flight, you're going to need a vertiport with multiple locations because it's all about volume. So there are really interesting concepts out there where you have these vertiports above highways. They look like pedestals, and you've got like 7 of these automated, autonomous vehicles flying out of them, and that really is the future. You can only do so much with a single vertiport, but this is where we are right now.
One of the notions that we've heard about looking at where to put vertiports has been really adapting existing infrastructure or buildings such as older, unused, or economically distressed malls. into vertiports. Is that
Yeah.
something that you've heard discussed? And, what are some of the benefits versus, limitations with that
Yeah,
concept?
absolutely. Great question. So I've looked at a state plan, like they've done it in Ohio. Michigan was looking at it, and they were indeed thinking of using the top of malls or even parking lots that are selling that are less that are not used as much, right? So what's interesting about that is airports are looking at that, because if you look at the trend in vehicles going into an airport area, even into malls, that autonomous part, right? So you get an autonomous Uber from your house. Let's say you pay $5, it takes you to the mall, it takes you back, right? So, but there's no more need for parking. So in the next 10, 20 years, airports are actually showing in their forecast that the parking demand is going to go down by 50%. So indeed, to your point, what do you do with that infrastructure? So right now, there are some master plans out there that look into the future. Is like, how can we use our parking deck, and how many vertiports or helipads can we put up there? So yeah, the industry's looking at that. Airport operators are looking at it. Malls are looking at it. I mean, to me, it's a huge commercial enterprise, where you could drive your car in and you could maybe take off, go back to the airport or go to a mall. 100% they're looking at
And nobody wants to park on the top deck, the uncovered bit.
that. That's right. That's exactly right. So
You got there too late when you, that's all that's left.
100% true. 100% true. Yeah. So, but what you bring a good point too. If you look, I'm just going to go down my slideshow here. I don't want to bore you with too many details, but from the Orlando perspective, what I wanted to show you is kind of this slide right here. So I'm not sure if you guys have seen this or on the news, but Lilium is a German company, and they have an eVTOL design with 37 electric jets. And it's really neat. I mean, I encourage you to Google that, because they have a cool video of this thing flying around. But they're pretty serious. They're backed by Ferrovial, a very large Spanish private entity fund that's based on pension funds around the world. So they've got a lot of backing, and they're looking at Orlando, right near Lake Nona. And if you know where Lake Nona is, it's near Narcoossee. It's a little bit east of Orlando International. But if you look at the range, if you look at that that area, they can pretty much reach Miami, Jacksonville, Tampa, the Space Coast. So even they were looking at, do we have any parking facilities at Port Canaveral? Do we, where can we fly, in what direction? So one of the things that we did as part of this project, we used GIS technology, to look at potential locations for these interconnected routes. Right. So even around the city of Orlando, we identified 40 potential vertiport locations that were within safe areas and airspace corridors. So again, if you look at that third bullet point, opportunity to connect 20 million Floridians within a 186-mile radius, which it's pretty impressive. And they just an FYI, Lilium is also, they bought land in West Palm Beach International Airport, and they want to start flying the commuter traffic West Palm Beach to Miami. Again, this is, we talked about this a little bit, Dr. T. That was the pricing point of this, right? So, we're seeing this for affluent people first, wealthy people that can pay $200 that don't want to sit in Miami traffic between Miami and West Palm. So I think that's going to be the first start of it. But the more you introduce competition and volume, the cheaper it gets, and that's the idea, right? So it's interesting. That's an often talked about subject, like who's going to fly these things first.
Well, and I see a lot of potential here for bolstering or augmenting the other mass transit options that we have. For you mentioned kind of Miami, West Palm, and then up to Orlando. We've got Brightline going in there, and hopefully in the next couple of years connecting all the way up, where there will be opportunity for folks to say, if they're in Miami, even though they could get on the train there, it probably might actually be easier for them to catch one of these, take it to the West Palm, where it's a lot less crowded, get on there, get in first class, and boom, off they are on the high speed end of this, to show up in Orlando to get their flight overseas or wherever, that Miami might not go. So there's going to be a lot of complementary aspect to it. And I see people switching in between, and it'll be interesting to see.
Yeah, I agree. And what's interesting? Initially, one of the big entities that we approached was Orlando International Airport, right? One of the bigger airports in the state of Florida. Their traffic's been increasing over time, but they were very much against this. They didn't want Lilium to come to Lake Nona because it's so close to Orlando Airport. It's right near the easternmost runway. And one of the things they were concerned about is like, well, we don't want these small little things flying around our airport. What if something goes awry or haywire or whatever? And they just weren't educated on the technology that's out there. Geofencing is a real thing. You can create the technology to have a geofence around your airport. As a matter of fact, there's a couple of pilot programs out there right now to protect airports from rogue drones or private drones that could, do damage at an airport. That's all being investigated. So the technology on the security side, the safety side is being developed as we speak. But from the piloting point of view, from the airlines, they were also not against it, but they were concerned because if an airplane's coming into Orlando and they're on final approach, they have terminal collision avoidance system. They have TCAS in their aircraft that basically says, hey, if I'm within a certain distance from a nearby object, that plane's going to go around. So imagine, if you will, you have these eVTOLs or these autonomous vehicles flying around the airport at 400 feet. All these airplanes are going to automatically go around because the autopilot says, oh, whoa, we're about to crash into an airplane because there's a corridor nearby. So there's concerns about the interoperability between airlines, aircraft, eVTOLs, autonomous vehicles, you name it. That stuff needs to be sorted out.
Yeah, I can see that happening there. And then, places like LAX, which, the density there is,
oh yeah,
is even higher. But the demand on the user side is already there. I mean, you mentioned, kind of earlier standards for rotary wing helicopters. And, you've got it in the tri-state area up in New York, New Jersey, Pennsylvania. You've got it in LA. You've got it in the places where, business meets high income, and where money is time perspective kind of takes root.
Mm-hmm.
So, yeah, it's going to be interesting to see how this gets pushed out initially to cater to the folks with the money to take it, but then it will evolve to adapt to the masses. And that's really where the true economic prosperity is going to occur under this.
Agreed, and I think aviation in the United States, I mean, it's getting to the point where even the autonomous aspect of it, and I know that that's what this class is about as well, with cargo companies like UPS and FedEx, even looking at maybe a single person operation, a single pilot operation, or eventually autonomous large scale cargo aircraft going into facilities. They've been looking at that technology because one of their pilots are expensive, labor costs are high. I mean, they're really looking at that, and that's kind of in aviation. That was the start of it, and now you've got these different types of vehicles that might be separate from an airport. From an autonomous perspective, it makes sense. So yeah, and going back to your point, Dr. Terwilliger, is I did a study for Joby and got to talking about what their markets were, and to your point, they're looking at the bigger MSAs, right? The metropolitan statistical areas. So they're looking at San Francisco, they're looking at LA, the New York area, and Miami, right? So those are the four. They're kind of covering the four different corners, and in that sense, it's really interesting.
Well, the piece that I've got probably the biggest question on is,
please,
getting into economic viability with weather. So Miami, things are great until we get into heavy wind and rainstorms. Out in New York, you've now got wind and winter, hail, blizzards, etc.
Yeah.
And trying to figure out, the operable use of this, because at the moment I wouldn't consider these to be all weather. I mean, we're still early days into the development of the technology. Most of it is sitting at 30 to maybe 60 minutes of operational endurance on the electric propulsion on the storage medium that they've got.
Yes.
So we're seeing the evolution of this technology. And you mentioned the 9 platforms that are out there, and it's kind of interesting. Some of them are very much hybrid platforms versus you look at like the EHang, that's a conventional multi-rotor, if as it were.
Yes.
So it's interesting to think how that weather might affect utility and usability of this.
I totally agree. There's a couple of advantages and disadvantages there. The technology. Yeah, I know, for example, at my university at Florida Tech, we started looking at technology where you can actually see the 3D visualization of corridors, right? And then integrating things such as ForeFlight. So, ForeFlight is one of those technologies that's within an aircraft that pilots use. They use their iPad, but it's now all interactive, right? So you can actually see the weather. You can see where the bad parts of the storm are. You can see icing not before it happens, but it is predictive. So a lot of that I think can be based on that technology, but it also probably needs to be monitored, right? So a lot of people talk about still having a control center, although it's an autonomous vehicle, and think in the future for someone to control that aspect of it. And then again, to your point, high winds. The one good thing about the multiple rotor element is that they're very adjustable, so they're quick to adjust. I don't know how far that goes. I haven't heard a lot about turbulence testing. I would be concerned about that. And the reason for that is I also do quite a bit of work in the Caribbean between the ABC Islands. So that's Aruba, Bonaire, Curacao. And they're thinking about establishing a link with eVTOLs, but also autonomous vehicles to fly medical packages back and forth. And if you haven't been to the Caribbean, especially the Southern Caribbean, I mean, I grew up there, so I know a little bit about it. It is windy. It's a windsurfing destination. It is 30 to 35 knots every day. And landing at that airport can be quite turbulent. So imagine, if you will, you've got a great model. You have an electronic vertical takeoff and landing vehicle that goes between the islands. Instead of paying $400, it's $100 or $50 because it's affordable. It's a quick flight. It's 50 miles away. But what about the turbulence? How do you handle that, right? So to me, that's all about technology. It's a concept that hasn't been proven yet. But I would be equally as concerned about things such as weather and any other type of weather elements that go into it.
So what are some of the more recent tech advances or breakthroughs that you've seen in this space that give you a lot of hope for us being able to break that the typical 10-year barrier where it's, oh, we're 10 years away from this, when in reality that's our typical placeholder. What are some things that you're seeing that make this that are enabling the maturation of this technology so that we might start to see feasible use case in
Sure.
Maybe a more advanced timeline?
But there's a couple of different things, right? So I want to start with the one of the concerns, and I know I don't have my slides up anymore, but when we talked about communities and what they're concerned about, of course, everybody's concerned about noise, right? So one thing that's really good about these vehicles, they just tested Joby at less than 40 decibels in overflight and taking in land up. So that's half the noise of a helicopter. So from a noise perspective, they've got that covered, right? Because that's one of the biggest nuisances in the general public from a certification point of view, from an environmental point of view. It's hard to sometimes get past those type of boundaries, but the fact that it's come out really low as an average, NASA is looking at it, is a good thing. It's a good thing for all of us, right? But then, in terms of the operability of these aircraft, what I've seen recently, and this is as of the last 2 or 3 weeks, I've been talking to a few firms that are now providing ground-based control solutions, right? So ground-based radar that is actually based on a fiber optic network for communication. So it is somewhat line of sight, but they plan to have certain antennas at certain distances to be able to perfectly control these vehicles within a certain range. So even if you're creating corridors between two big cities, you can create those corridors along highways, right? Because there's not a lot of airplanes flying low over highways. So you establish those corridors, but with technology that monitors the vehicles themselves. So that technology is coming around right now. They're pretty short range. They're between 15 and 50 miles. The biggest question is, how do you upscale that? How do you create a giant network out of that? So there is some infrastructure that's actually associated with that, but it is a viable solution because it controls the vehicle without any disruptions in the service of being able to monitor the vehicles. So I thought that's pretty neat. There are airports that use ground-based radar just to control their taxi in and taxi out operations, and also situational awareness for pilots. So it is something they can see on their screens. The controllers can see it. but that is pure radar. For UAS, what they're seeing is a combination of radar and potential antenna infrastructure that sends immediate signals to those vehicles. So that to me means that yes, there's ground-based solutions where we can have a system in place between certain corridors and distances.
Excellent.
Yep.
As a professional in this space, we see a lot of material put out there. Whether it's painting a rosy picture or it's screaming that the sky is falling. What tools or resources do you personally use to stay informed, and what are some of the challenges that you find to sift through the huge, voluminous amount of material that's out there?
Yeah, that's a good one. I do follow the manufacturers, although they're very coy about sharing information. A lot of it's confidential. So that's one of the reasons the FAA had a problem with creating, the vertiport dimensioning, because a lot of that stuff is proprietary, especially in terms of the capabilities, right? The range and the operability of these things. But yeah, I follow the FAA. I go to a lot of different conferences. There's 3 different types of conferences out there, but from an airport perspective, it's the #1 topic. I was just at the American Planning Association. There's the American Association of Airport Executives. There's the Airport Council International. A lot of this is being presented in the airport world, and it's just getting to the city aspect. So one of the things that I also follow is city planning, comprehensive plans. Every city usually does a comprehensive plan every couple of years, but it really helps talking to some of the city planners that also often talk to the states. So FDOT actually has an advanced air mobility program. They don't talk about it a lot, but and it's also who you know in the industry in aviation, obviously. But I think that the main sources are FAA. I watch what the Europeans are doing through EASA. And if you follow what's happening in China, I mean, they're all about integrating that technology as soon as possible. But yeah, they're just really not one source, to your point. I hope I answered that correctly, but yep. Yeah, industry trade associations are huge. I would say, really follow the manufacturers, because they do put out daily news blurbs. Follow the airlines. Look at what the airlines are doing. They're investing money in this. Follow the car manufacturers. Toyota is a large owner of Joby, for example. Hyundai is creating their own vehicle. So they're really, you got to follow the bigger guys. And then eventually we're gonna compete with Tesla and their boring company, right? So we're gonna go underground. So it's gonna be good for
diversity of opportunity.
Yes.
Yeah, I was gonna ask you if your presentation, if that was APA out in San Diego.
It was APA. Yep.
Wonderful.
Yeah, well, I mean, yeah, and if you don't mind, while we're talking on it, I'm gonna try to share this one more time. Hopefully you guys can see it. But just to get you an idea, right? These are the stakeholders that we've been working with. So we were responsible for putting all these people in the room saying, well, how do you guys see this? Where can we put these things? What's important for you? So just take a look. FDOT, City of Orlando, counties, local governments, the Turnpike, Port Canaveral, Space Florida. So the spaceport integration part, these were just half of our stakeholders. Universities, you see UCF there. Of course, we're going to say boo because I'm Florida Tech, you guys are Embry-Riddle, but at the same time, this is kind of what it takes to get to a consensus of, building out some sort of infrastructure for advanced air mobility.
Outstanding. Well, now I'd like to offer, if any of my students, now is the time for you guys to raise your hands and ask any questions you might have of Finn. We have one. Okay, Jason, if you want to start, and everybody else, if you want to start thinking of some questions.
Yeah. Hey, Jason.
Hey, Finn. Hey, thank you so much for the presentation. This is very interesting stuff.
No problem.
One of the things I had, hold on, Rosie. Sorry, my daughter's listening in, right? So
it's probably eating time.
Yeah. I just got home from work. Actually, I'm on the West Coast, but so one of the things I considered with this whole concept of autonomous, vehicles giving rides back and forth, and with the air aspect of it, is there any consideration to using already in place structures or, like freeways, essentially. You know, you have freeways and they usually have a buffer on the outside of them, or a center lane that goes in between the traffic, and using that as like your like VFR corridor as an aviator, you know what I mean?
Yes.
Because then you can fly them super low to the ground. You don't have to clear too much more land, and it allows you to have main access in and out of roadways.
Yeah, 100%. You know, highways are the first quarter that's up in Syracuse, for example, is exactly above a highway at 400 feet, right? So it's an established, you know, to your point, like a quarter, not a VFR necessarily, but a specific drone quarter that flies at that altitude. I've also seen concepts in the city of Los Angeles where, you know, along the 405, I believe, where they can build vertiport locations above the highway. So you can pull in from a highway, it's actually situated above the highway, and you can use that to come in and out and take your car from the highway to wherever you're going to be working. So absolutely, I think highways and you know, major roadways are being looked at from that perspective, because that's still the free space that there's nothing above it, you know, I mean, up to a certain point. And I think it's ripe for infrastructure. And it's almost like, you know, what they're doing in places like Japan, where they're creating double-decker highways because they're so saturated with, they can't build anything else. Everything's going to go vertical. And for these vertiports, it would be the same thing, I think. So great question.
I had a follow-up to that one, if you, if I could.
Yeah.
So with the issue of being in altitude, is the 400-foot marker largely for like safety, for like a parachute system or some kind of recovery system if there was an issue? Or is there an issue with getting lower to the ground? Because I feel like if you could get lower to the ground, that would allow you to eliminate some of those airspace restrictions that you have.
I've heard 400 feet thrown out just you know, to stay at above most major power lines, you know, or lighting devices along highways. I know that seems like way up there if you actually look at that. But just, yeah, to your point, I've heard of some drones that will have parachute systems that at least gives them a little bit of free fall on the way down. I think that's why. Don't quote me on that, but I know that the FAA has thrown out that 400-foot number and above for those type of corridors. So yeah, I would think that's a safety perspective. But you know, if you're lower, again, you know, you're absolutely right. If the momentum of that UAS element, if something happens to it, but at least it gives it a bit of a cushion to be able to, you know, veer off its regular path or go somewhere where it's a little bit safer. But yeah, that's it. It's a good point. I don't think they've agreed on certain altitudes yet, but I know they have to stay below whatever quarters there are in controlled airspace with other aircraft. Good question.
Thank you.
I think they're still trying to figure some of these things out.
Next up, we have Shelly.
Hi, Shelly.
Hey, thanks for the presentation. That's all pretty interesting to me. I grew up in Florida, so all of those places you were talking about are real familiar. Okay. So I kind of have a two-part question. The first part is, speaking of corridors of like interoperability and trying to avoid the manned airspace, over water flight, I know like that whole area is probably the less trafficked area, but how does it compare to like the risk of then over water flight for these type of vehicles?
Good question. I haven't seen any studies that have looked at that. You know, I think there's and I mentioned it a little bit earlier, you know, having grown up on Aruba, they're looking at that, you know, over water flight between the islands. And it's not really a safety element or not. I think you can probably go as low as possible. But the biggest part there is getting clearance between those two elements, right? So working with your local FAA in the Caribbean, it's the DGAC, trying to get approval for those different overflights, right? But I would think that anything over water would be similar to what's required for regular airplanes, right? So it's also an equipment thing. If you're going to be flying people back and forth or longer over water stints, you have to have certain flotation devices, equipment and gear. So you probably have to design, if it is, you know, autonomous vehicle with humans in it, they should have some sort of safety devices if they do land on water. I don't think that's going to change. But from an autonomous package delivery perspective, I don't foresee any problems with it. But again, it's the airspace compliance and approval elements that are going to be important there. I would still say we have to probably create corridors, just like flying to the Bahamas. You know, there's just I think Jason had said that there's VFR and IFR corridors. I would think you'd probably have to prescribe to that. So that way, at least other pilots know that, hey, that's a drone corridor. those are autonomous vehicles. They're not piloted. I'm going to stay away from that. I'm going to stay at my own altitude. So there has to be some sort of airspace coordination, I would think.
That makes sense. And I've noticed like certain states such as Nevada and Florida are a little more ahead of other states for regulation for this type of like innovative technology.
Correct. And that's one of the problems, right? So there's not a lot of consensus. States are just starting to look at it from an overall picture perspective. Cities like Orlando are being proactive. Tampa's starting to look at it. Miami it's a trend, right? This Orlando one's one of the first. And everybody's like, oh, wait a minute. I think we can do that. And they all see money making opportunities as well. So it's, yeah, and you're absolutely right. Some states are behind and some states are really proactive. So I think some people are going to get left behind.
Right.
But it keeps consultants like me in business, right? So I can go to states and say, hey, we did this, for Orlando. Now let's do it in Albuquerque. It makes sense or whatever. Come up with a business model and then we plan for it. And that's really what's let's plan that infrastructure.
That makes a lot of sense. And so last question I had. So my unit actually developed a UAS corridor between the base and the restricted area that they want to operate in. Do you think that like military units starting proving these corridors is really what's going to bring them into the mainstream? Like I know that happens with a lot of technology. It kind of comes out military first and then goes to the civilian side.
Well, I think actually the reason why we're starting to look at corridors and things is because it's coming from the military. To your point, again, I use Syracuse as an example. That's actually a joint use facility. They've got Reaper drones up there, and they do touch and goes all day next to other aircraft. I've flown in there on a 737, and next thing you know, you see in the pattern, you see a Reaper drone flying around. But they have established corridors, just like what you said, between the practice area that's over the airport and their another base, a training base. And those are restricted, right? So it's kind of the same concept. And they've established altitudes, but those are tactical. So it's now just a matter of adjusting that to what the commercial applications are. But a lot of the technology comes from there. So yeah, good point. I think I know in our industry we look towards the military in terms of how they've established themselves.
And that corridor would be from Syracuse Hancock to Wheeler Sac up at Fort Drum.
There you go.
That's my hometown.
Yes, you know about it.
I cut my teeth with an internship at Syracuse Hancock when I was
no kidding. Okay.
A junior in college.
There's a lot of things going on, man. A lot of things happening right now.
Outstanding.
That's all I had. Thank you.
Thank you, Shelly. Good questions.
Anyone else have any questions for Finn?
Oh, got a couple. I got Bernard Shaw, great name. Bernard.
Hi, yeah. One thing that I heard you mention is about the decibel rating for some of these autonomous VTOLs predicted. Is that only for electric VTOLs or is that everything? Is there also a consideration for ones with internal combustion engines?
My understanding right now that there's only one that's really been tested in that sense from a full NASA test facility, multiple months of testing. That's Joby. And they are electric, and that was right around the 40 decibel level, I believe, which is considered low. I am not privy to information from some of the other OEMs. They really haven't come out with that information. Joby was kind of the first in that sense. But from the combustion perspective, I'm also curious to see how that would work with hydrogen-powered aircraft, right? Because there's two ways. There's the HVTOLs and there's the eVTOLs. And both are being looked at, with hydrogen, of course, being a little bit more combustible. There's a lot of concerns about hydrogen, even though the technology exists for cars. The byproduct is water. It's a wonderful thing, but again, it's a good question. All I know is what I know about Joby, that it's a lesser noise element. But the problem is volume, right? So if you know a little bit about how average day and night level sound requirements are for an airport, there's a 65 decibel threshold over a 24-hour period, including a 10 decibel increase at nighttime. So there are standards, right? So for airports, for example, we have to do noise studies and we have to mitigate anything that's within this 65 day-night sound level contour has to be mitigated because it's too noisy for normal human recreational patterns, right? So I'm just wondering with the higher volume if that's going to create a different noise footprint. That has yet to be tested. So they're looking at the technology and how quiet it is. But if you enhance that by multiple volumes of operation, it might be a different element. And what's really interesting, and sorry to brag on about this a little bit, but we had asked some of the stakeholders, hey, are you concerned about noise? Yes, they are, but they said we're concerned about something else that's a lot more important for us. And this was from the folks in West Palm. And if you think about West Palm Beach, a lot of affluent people, there's a lot of wealth there. They don't want to see 1,000 of these vehicles flying through their skies, quotation marks. So it's the visual noise that is becoming an issue. We're hearing that from multiple stakeholders, multiple cities, multiple states. We don't want 1,000 of these things just flying around like Jetsons. We don't like that. So there's that annoyance factor that's visual, believe it or not. That's kind of becoming more to the forefront as opposed to noise. And I thought that was just super interesting. So yeah, Bernard, I didn't answer your question fully on that. I think people are still out on getting information, but they're definitely about half as noisy as a helicopter.
Yeah, I'm going to share some information tomorrow with all of you in the discussion area that's got some eVTOL players, some of the keys. One of them is it's an investor guide that talks about kind of the timeline, starting with Uber Elevate and going through to, some of the key players like Finn mentioned with, Toyota and Joby and, who Fiat is involved with, et cetera. That'll give you some idea of what these platforms look like as well. And, if you want to dig in, that's a good place to start.
Yeah, and Bernard, to your point, there's that lithium one has 37 electric jets, and it's kind of a hissing noise. So there's different types of elements, right? It's not like unlike a jet engine, but there's different sound elements, right? So it's a different type of sound too, and they're concerned about that as well. But that's what I know at this point. And I think Mr. Thomas Talley had another question as well.
Greetings. Again, thank you for your presentation.
Sure.
I got a couple of questions.
Shoot.
One of them is, until there is automation, obviously there's going to be a need for pilots.
Yes.
So what is the effort for training? This may be more of
I think, Thomas, I think
like, is Embry-Riddle going to start providing?
I think Thomas is coming in and out a little bit. I don't know if you're having the same problem on your end.
Yeah,
It's a little intermittent, Thomas. If you want to type your question over in the chat area, but I think what I got out of your question is if what the pilot certification is going to look like, and then what the subsequent pilot training programs would look like, and if groups like Embry-Riddle and FIT are going to get into that, to which I would say almost definitively yes.
Yes.
It's just a matter of what the timeline looks like. I imagine we'll probably be looking at adapting what we have in place, use of simulation, et cetera. But at the end of the day, it'll be most likely a consortium of common flight schools, universities, et cetera, that are in this space, groups that are part of organizations like UAA, University Aviation Association, will probably come together in concert with the FAA to help them make the determination of what do flight training programs look like for this new certification.
Correct. And I don't think it's too dissimilar to what's happening with the operating certification requirements to fly commercial drones, right? So, which is essentially like a basic pilot license, but up to certain weights and pounds. So I think there's going to be different levels of that certification. But Dr. Terwilliger, I think you might agree with me that I think in the near future, yes, they have to be piloted type of aircraft, so that pilot has to be there. But the idea that some of these OEMs are toying with is that the aircraft itself is still controlled from a central location by a remote pilot, and that there's just somebody that's a pilot that's either sitting in front or just there just in case, that is monitoring the systems. So there's a couple of ways to look at that. And one of the things that, for example, Florida Tech is focusing on is the drone pilot aspect of it. So somebody that sits in front of a computer and is operating that drone remotely. There's a lot of investment in that. I was actually able to visit the 174th back, and I keep going back to Syracuse. But those Reapers, my understanding is, from a military perspective, they've got antennas strong enough that the reaction time between a controlled aircraft, and even if they're in a place like Afghanistan for military purposes, is less than half a millisecond, just because of the technology and the antennas, right? So that's military classified technology. So it does exist. So that, to me, it's a hybrid, to answer your question, between, yes, there will be a need for pilots on different levels, They probably get paid pretty well for a while, but then that remote aspect, I think that's where things are going. That's my personal opinion.
I will say just a little bit of a correction there. There is some latency. Um, that's why they do a lot of takeoff and landings within 300 nautical miles, is because should they get hit with that wind gust on final, that could be disastrous.
Absolutely, absolutely.
Yeah, I was about to say they normally for a normal flight, they will transition to a local GCS for landings and takeoffs.
So what in that case, and this is something that we might see occur, as we look at automation and autonomy and maybe remote split ops taking place in manned aviation world, altitude is the trade-off. So if you're operating at 10,000 feet, well, then that latency, the effect of that isn't as severe. You have a lot more time to recover. So that the same could probably hold true for operations if you're trying to to take over a flight and route and do things of that nature. It's those local operations that we have to figure out how are we going to do this. Now, I will say there's been tests domestically where when you can run through fiber connections, you can go coast to coast and the latency is minuscule.
Yes.
Because you've changed mediums. It's when it's UHF rather, and VHF and our conventional comms methods. That's you're essentially, you're not going straight to the aircraft in those cases. You're bouncing up. You're going up to a satellite to go over, and it's through that extended range of that signal distance. That's what's introducing the delay. But it's cool stuff. I mean, when they're doing what they're doing there, it is, you can't even tell the difference when it's local ops.
It's absolutely amazing. Yeah.
And speaking of pilots, with respect to the vertiports, are there going to be instrument approach procedures developed for IFR conditions?
Yeah, and I think that's a very good question. I've asked the manufacturers the same thing. I would think there's got to be a system for that somehow. There's not a lot of heliports with instrument approaches. They do have them in some areas, but number one, they're very expensive. Number two, they typically require maintenance by the FAA. So anytime you have an instrument approach at airports, who maintains the ILSs and things like that? It's the FAA. So it's also an ownership issue. So not only from a vertiport perspective, do you have to be concerned about the infrastructure and the obstacles, but also maintaining that to a level that is typically a federal level. That's my opinion on it. I don't know if you guys have heard this, but the other technology that I've heard about is very similar to when some of those rockets from Mr. Musk land it's the laser ranges, right? So when you're coming down vertically, is that it's all based on understanding the altitude and the descent rates and things like that, because with a vertical aircraft, that's maybe a little bit easier. So geofencing comes back into play, right? So if you turn geofencing around, can you have specific sensors that adjust the aircraft towards landing? I mean, it would be really cool to see kind of an instrument landing system that's not radar antenna based, that's more laser based. Or, back in the day, they had the MLS microwave landing system that was very accurate. That's what the space shuttle used, right? So maybe there's some sort of a system like that. And to answer your question, Thomas, I mean, I haven't seen anything yet, but it's got to be possible, and not where it's like $1 million to buy an ILS system. It's got to be something much easier.
And the laser may be iffy only because I'm here also in San Diego, and I fly in and out Carlsbad Airport. Mm-hmm. And many times the marine layer will roll in and basically the airport is wiped out. There is zero visibility. So are you going to get a laser through that marine layer?
Yeah, maybe that's more radar altitude related, so you're absolutely right. I mean, that might affect it. And normally from a pilot perspective, you go to your alternative, right? If there's a marine layer over all of California, I went through one when I was there last time. Yeah, I can imagine there's some challenges there, right? So, again, it's also, the technology with forward-looking infrared radar and, three-dimensional, what do you call it, quarters that I've seen that are set up based on certain GIS locations, waypoints. I think there's opportunities and possibilities. I just don't think they're there yet. But I believe the technology, it's got to be capable somehow, but they haven't thought that far yet. I think they're just worried about the operability from a VFR perspective, unless Dr. Terwilliger has heard differently. I haven't seen anything yet, to be honest with you.
No, not yet. And, I think that's
Great
getting
question.
into things like that I've got questions for, I played a part on the ConOps for the urban air mobility that Deloitte and FAA and NASA kind of put out back in 2019 to 2021. During that period. I provided comment and review on that. And where I had question is some of the interoperability that's going to occur with existing rotary wing. Just because right now with UAS, we're starting to see challenges on that front compared to, we'll say fixed wing, conventional fixed wing operations. Because those folks do operate in that same space, in that lower altitude. And it's different, how they fly is completely different. So it's, I think that's where UTM and things like that are going to play a critical part in, carving out the corridors. We'll probably have to have exclusion for rotary wing to come in there, so that it's pretty much safe passage for everybody else. But yeah, it's still, this is all a work in progress. It's really interesting to see all the different perspectives and voices that have come out for this. And, a challenge like, we just identified with determining trajectory to come in to the vertiport under weather. If we don't have an answer now, we will. And this is something that starts in an academic setting like this, and then it bubbles to the surface, and then next thing you know, the OEMs they've got their top people on it. So it's kind of interesting.
I was thinking exactly the same thing. There's a great dissertation or thesis in that somewhere, right? So even a literature review of, okay, what kind of systems I've worked before, like the microwave landing system. Why was it only used for the space shuttle, right? I mean, laser technology doesn't go through a marine layer. I love these questions because there's so much there that I think we can help the industry with. And you're right, it starts at the academic level. Yeah, good point.
So I think, Jason, did you have a second question or?
Actually, I just kind of wanted to talk about the ILS landing system. Do you think there'd be any use of using like the TAL system that the military currently uses, or Sierra Nevada Corporation actually has developed a great DVE landing system for helicopters to give pilots the ability to see through brownout and whiteout and things of that nature. What they use is they actually use a combination between radar and LiDAR on that. And then the LiDAR ranging also depends on the UV spectrum which the laser falls in, and that gives you an increased range if you use specific UV rays or UV frequency ranges, basically.
Yeah.
Do you think there's any? Go ahead.
No, I'm thinking that's some of the solutions, right? And how that plays out for me, Jason. That's because that you're talking about technology that's within the aircraft, right? So the other part of it is if you do have a vertiport somewhere in the city or an area, how does it work from the ground up, right? So what's the infrastructure? Because if you look at the ILS and glide slope, I mean, these are big boxes, big radar beams, right? So if you have that technology, even if it's UV light, yeah, they can see, but they're also, do they need that guidance from the ground, right? So that would be my big question there. But you're right. I mean, and I'm sure the military is using that to some extent that we don't know about, to your point. So I see those as solutions, to be honest with you. I think it's a great conversation to have.
Yeah, with the TAL system, if you look up the TAL system, TALS is Tactical Air and Automated Landing System. Yeah. So it actually is not a large integrated operation system. It's a small radar, a small transmitter receiver with some backing behind it. And then it actually communicates with a small system on the aircraft, which can be installed. And then it communicates and gives it everything it needs. Yeah. And then the degraded visual landing system could actually be only installed on the aircraft. It doesn't require anything from the ground at all. And then when you're talking about an automated system, you're no longer relaying that information to the pilot. Then you're just inducing it back into the algorithms that are going to land the aircraft.
Awesome. And then I'm learning some. This is great. And then the question is, what the industry and the FAA would want to know is what's the reliability, right? So testing. So if that's something that's proven that exists, I mean, awesome. But there's always a gap between military and commercial applications that has to be bridged.
Right.
And
Right.
I think, to your point, I think it sounds like it's absolutely viable, right? But it's all about transitioning that and having the FAA comfortable with it for a larger scale and reliability applications. So that's awesome to hear, man. I learned something new. I'm looking that up
Yeah.
for sure.
Yeah, I was on the carrier when they were doing the UCAS testing, and they were able to select which wire they wanted to test. If you know anything about landing on a carrier, it's pretty hard.
Yeah.
And they've got four wires they can pick. And so typically the 3 wires the gold standard for all pilots. Well, the UCAS could land on the 3rd wire every time they wanted to. And then they said, you know what, we'll switch it up and hit number 2. And they hit it perfect using this system. So
that's cool. See, that's amazing. And again, coming from the military side, right? So yeah.
Right.
Yeah. I'm glad to hear that. It's awesome. Thank you. Good stuff.
Well, outstanding. I want to really thank each of you for joining us tonight, and a huge thank you to Finn. This was a really informative and enlightening session to help us further understand, what's going on in the urban and advanced air mobility space, the challenges, the exciting developments. Class, remember to receive credit for your participation this week. You need to develop just a brief overview to drop into our discussion 9. It addresses, how Finn, how VHB is demonstrating the feasibility of operations that are going to help influence use and integration of the technology. That could be creation of new services, economic opportunity, or use cases. Then how lessons learned or observations made can help you make, or how the observations made by our guests can help to make such developments either more viable or sustainable. And then any new information that you were not previously familiar with, including how your overall understanding of the topic has improved. I'm also happy to stay on and chat if any of you have questions, or if you want to pick my brain regarding this week's activities. I know it's the last week. There's a few things still left, and I've got your final papers to still go through. I know I sent some comments back to a couple of your groups just so that we can kind of put those finishing touches on and make it, the best possible effort. So I'll be happy to stay on. With that, thank you, Finn. I really appreciate you joining us tonight, sharing your knowledge, and it's been really good. And if you get a chance, I'd like to catch up sometime and just talk about some of these developments and find out a little more about what's going on in Syracuse.
100%, and you're welcome to do the same thing that I did here at Florida Tech. We'd love to have that interconnectivity. So I really appreciate that. Thank you for having me here. Hopefully I gave you kind of a broader overall big picture. I'm a big picture guy. But that was a lot of fun. I learned from you guys too. So thanks for having me, and have a wonderful evening. I'll be in touch soon.
Sounds good. Thank you.
Awesome. Thanks, guys. Enjoyed that. Thank you. Have a good night.